Hi, so I brought this kit off Banggood. Now this is it's down as an XR2206 function generator DIY kit, sine, triangle, square wave output, 1 Hz to 1 MHz. This is the item here on Banggood. It's currently at $7.69. Now when I brought it, I suppose I ordered it about 3-4 weeks ago now. I've had it for about a week and a half. I paid £6 for that. So it's gone up a little bit in price, and yeah, you can see it's quite nice, got a nice little plastic case. Okay, so here's all the bits in the bag. We'll start by getting them out and see if we've got everything we need. Hopefully we have. So we've got some information here. This will probably be our circuit layout. Yep, so circuit layouts and some information, debugging steps, and general use of the thing. So I'll pop that there. So we got little wooden, sorry not wooden, is it? Plastic Perspex type casing, and we got our bag of bits here. Right, that's all the bits out. So we've got our chip here. So what is our chip? It's got on it 2206 CP, underneath that F0919. I did look that up before. I'll link in the datasheet anyway for that. Got some plastic knobs there. Screws there for the case. And where is our circuit board? Ah yes, wrapped up in this. And it's all falling out everywhere now. Right. Those bits to the side. So here's our circuit board here. So, where do we begin? Well, I would say resistors. So what have we got? We have got R1, how many resistors have we got? 1, 2, 3, 4, 5, they're all the same. Let's have a look. R1, R4 is there, R3, R5 there. R6, we got 6 resistors? No. 3, 4, 5. Some capacitors there. I don't see a 6 resistor, but we have got on here R1 there. R2 is shown as not populated, so we're missing that one out. So R1 is 1K. R2, alright, that's one of the adjustable pots. Yeah, that's fine. And then we got R3, R5 and R6 are 5.1, and R4 is a 330. Okay, so I've got all the resistors in place on the board now, and just going to apply a bit of flux. I bent the leads over, that keeps them holds them in place while you're soldering. Okay, so that's the IC holder in place now. So we've got our electrolytic capacitors, and we've got our jumper links there, header pins. So electrolytics, we have got C1 is 100 microfarads, so that's 10. 100 microfarads there, and that's for C1, so that's going up here. So checking for polarity, so negative is there. Have they got the negative marks as the ground? I think that's correct. What we can actually do, if we know the ground point on our input, Yeah, that looks correct. So I think the hashed area is the ground. It normally is. So we'll just bend those legs out a bit just to hold that one in place. That's that one in. We'll crop the legs, and that's sitting nice and flat on there, which is what we want. I think there are plenty of cheaper alternatives to this board. They're obviously going to do the same and act as a function generator. But I quite like this one because we've got the nice little plastic case to put it in. It makes it a bit neater. So let's go for C4, which is 10, which is that one there. So again, put the negative to the hashed area. Of course, if I've got this wrong, this isn't going to end well. I had a few issues with the camera recently. Did it just now when I was setting up for filming. It's the Canon Allegra, what was it, R506, HF R506. I suppose it's over a year old now. But occasionally you turn it on and get it set up, and you just get a very sort of blue tinge to the whole image. Not quite sure what's causing that, but it does tend to go away once you turn it off and on again, so to keep my eye on that. I don't know if it comes out on the video or if it's just actually on the LCD itself. I would have to wait until it does it again and actually record something like that and see how it comes out. So this is our last capacitor. Okay, that one need a bit more reflowing, I think. It's balled up a little bit on that. Probably need to clean the board up, a bit of isopropyl alcohol. So we got some jumper leads there. Got a output connector block here. These ones as well, you'll see that you've got the you've got this area here marked out, so obviously this will go in any way round, but if you put it in that way round, you're covering up your areas and your cables are going in that side, so make sure you got it the right way round for your cables to go in on that side there. And with these, try not to keep the iron on there too long, as they are plastic and they will melt. Right, so we've just got our potentiometers to go on, and pop our chip in, and our I think I'll tell you what, put the DC barrel jack on first. Be a good idea. So always better to put the smaller components on and work your way up. Okay, so that's our power connector connected, and now we've just got our 3 potentiometers. I believe these are all exactly the same. We've got one R7, R8. What have we got here? R7, R8. They are different. Just to confuse you, so R8 is B104. We got any markings on these? B104, so the markings on these are on the underside. So that's B104, so that'd be that one there. These are quite good with the little tabs they've got here on the outside that you can solder in as well, just hold it in place. They seem to be pushing in the holes and then locking it in, which is quite good, so we should be able to get them all in and then solder them at once. So R7 is 503, which is that one there, that's good. And then that will be our last one there. So just get those soldered in, and then we'll be ready to start testing. Okay, so we got those all soldered in, and I've soldered all the tabs along there as well. So now it's a case of putting it in this little case, which has some screws as well to hold it together. Which you don't get any instructions on how to put the case together, so that's case to figure it out yourself. So it's really just a case of peeling this off on all your plastic pieces first, and then you'll be ready to start assembly. So I'll pause the video here and I'll come back when I've got that together. Alright, so I finally got the case on. Believe it or not, that was the most frustrating part of this. Getting all the plastic bits to line up is one thing. And they give you these little machine screws, the little nuts on it. Now they're designed to go through these bottom holes here and hold the circuit board in. But they're not long enough. No, unless you cut down all the your solder joints really flush, you're not going to get that in. And disappointingly, the ones that hold the actual case together are just self-tapping into the plastic. So yeah, it's holding it together for now, but that will need longer ones going through with some nuts on the end, I think. Yes, poor design there. So I just need to find something to power it with, and I've got the oscilloscope ready, and we'll have a look and see if it works. Okay, so I've got this rather crudely set up. We've got the power supply connected across with these enormous clips there into a DC valve jack. I'm currently giving it 9.5 volts. It says it runs from 9 to 12 volts. I've got it hooked up to the oscilloscope. I've connected 3 wires into our connector block here. So we've got our ground connection over here, and then we've got on here our outputs are for sine and triangle on the orange and square on the white. Okay, let's try not to short everything out. So if we hook up on our sine wave, you can see we have got a sine wave there, but there's a lot of noise on that. We can't clean it up a massive amount. As you see, there's a lot of ghosting on that image there. I don't know how well that's coming out. I'll zoom in a bit on that for you. So as you can see there, a lot of ghosting of the image. So that could be something to do with the setup that I'm powering it. Certainly interference in the power supply would be one thing. So we'll try a different one. I've noticed that you've got these jumper links on the board, and you can select between your square, I think this is square and triangle and sine wave. But the sine wave one, that's with the jumper off and that's with it on, so there's not a huge amount of difference in that. So I'm guessing that if the jumpers are off, we should be able to output a square wave. So we will connect over to, and yep, there's our square wave. Again, you can see the rise looks quite clean on that, but the fall is got that ghosting down the side there. So that certainly seems on that one, it seems to be the rising edge is fine there. That's interesting. So that should be, I think that's supposed to be a square wave, but that's much more like a triangle. It's just put the oscilloscope on auto mode. So that's certainly some kind of triangle waveform. Yes. Let's put the jumper link across onto the triangle. So that's on the triangle. So if we hook up both jumper links, does that make any difference? No. There's certainly no difference there. Going back to that one, that's our sine wave there. So we can get some kind of triangle wave. Yes, I wouldn't. It really is quite a fair mess, isn't it? That's yeah, it's not. The amplitude is not really doing much at all, so then we may have an issue with that. It could be causing the problem. But yes, we got very messy triangle, if that's supposed to be a triangle wave. I'm trying to get a square wave, which I'm guessing should be jumpers out. Should give us a square wave, and we've got nothing. It's just exactly the same as it was before, and I don't think the voltage is going to make much of a difference. Just going to change the amplitude there. So the voltage going into the unit certainly doesn't seem to be the problem there. So we can certainly get some kind of a triangle wave, and yes, some kind of a square wave, sine wave there, but not a very good one at all. Yeah, that's quite. Let's trigger off that. Yeah, that's quite poor. And with our sine jumper in there, actually adding more noise with the jumper connected. There's a lot of touching about on this is making quite a difference to the waveform there. So the amplitude does seem to, adjustment is working on that, so we can get that a bit better. But yeah, that ghosting there really is a bit of a problem. So I think we've got an issue on this. We've certainly got some information in the instructions on debugging. Pay attention to the direction. Yes, we've done that. Check the IC whether against, such as anti, please timely correction. Sorry, I'm off camera there. It's not very helpful there. Insert power supply for 5.5 2.1 port, sensitive positive, barrel negative. Yeah. So it says above 12 volts the waveform will be unstable. So we've got, so if we put jumper 1 plug into sin triangle, blue terminals, output sine wave. Note jumper 1, jumper 2 can only insert one of. Triangle, square, blue terminal, output pulse. Yeah, we can certainly say that's not working as it should, so we shall have to do some debugging on that in a upcoming video. So could it be that we got a bad solder joint somewhere? That's always a possibility. Or is it generally that this kit is blatantly rubbish? If any of you guys have got one of these and you've put it together and it's working better than this, then please let me know, and hopefully you can sort of point me in the right direction as to what I might be doing wrong with it. I should certainly play around with different power options. I'll get a PP3 connector and just connect a 9-volt battery up, as it may be that the power supply is, because it's right next to it, is inducing some interference into it. But anyway, so hopefully you found that video interesting. I certainly did. I was kind of hoping it would have worked better than this out the box, but that's all part of the fun really. So yep, it may even be that I've got the oscilloscope set up wrong at the minute, so I will look further into that. But yep, something to look into there, and I'm sure there will be a future video over the coming weeks sort of exploring this further. So if you found the video useful, please give it a thumbs up. Any comments, please leave it in the comments box below, and I'll see you soon for the next one. Thanks for watching.